This video is going to be centered around systems of equations, but solving them using elimination. Before I do that, I'm going to start off by asking if this statement is true. 4 plus 3 equals 7. And you should know that it is true. So pretty much what elimination is centered around is taking something like this and being able to actually multiply the entire thing by 2. Does it stay consistent? Does it stay true? So 2 times 4 is 8. 2 times 3 is 6. 2 times 7 is 14. So does 8 plus 6 equal 14? Yes, it does. It remains true. All right, so the point is that you can take any of these equations and multiply it by some scalar or some number and make the number and just change the way it really looks, but not change the truth of it. So that's what we're going to be doing with elimination. We're going to do that to these equations so that when we add the equations together, one of the variables actually ends up canceling itself out, or eliminating, if you will. So that's why it's called elimination. So the easiest way to do that, and I could explain it in other ways, but I'm just going to go with the easiest way. If I wanted to cancel out the 7 or the x's, I'd multiply the top one by 7. I'd multiply the bottom one by negative 5. So when I multiply the top by 7, it'd be 35x, and when I multiply the bottom by negative 5, it'll be negative 35x. And when I add them together, eventually they'll cancel out. So let me show you this way real quick, before I actually multiply by anything. If I added them together at the moment, I'd end up with 12x minus 6y equals 52. This is what I mean by adding them together. Add the x's, add the y's, add the numbers, but this doesn't do me any good. I don't know why I said 6y. It should be negative 2y. Still, this doesn't do any good. I still have x's, I still have y's. We didn't eliminate any of the variables. So we need to multiply these by something before we proceed with that. So let's go ahead and do that. So let's go ahead and get rid of the y's. Let's say we want to get rid of the y's. I'm going to multiply the top by 6 and the bottom by 4. And when I do that, let me go ahead and write out to the side what it is. So 6 times 5x is going to be 30x. 6 times 4y is going to be 24y. 6 times 12 is going to be 72. Then the other equation, if I multiply by 4 on everything, 4 times 7 is 28x. 4 times negative 6 is negative 24y. And 4 times 40 equals 160. Again, now that I've multiplied, my objective is to add them together to get things to cancel out. The 24y and the negative 24y are going to cancel out. That's exactly what I wanted to happen. 30x plus 28x is going to be 58x equals 60 plus 72 is 232. Now I just need to divide. So I've got x divided by 58x divided by 58, 232 divided by 58, so x equals 4. Now much like substitution, once I get that, I can just come back up here and substitute this 4 into any one of these equations to find out what y equals. So let's use the top one, 5x. So I've got 5, and I know what x equals. X equals 4. So I'm going to take that, and I'm going to plug it into this equation for the x. So 5 times 4 plus 4y equals 12. So I rewrote this exact equation, except instead of using the x, I used what x equaled, 4. So I've got 20 plus 4y equals 12. Continue going with this. I've got 4y equals negative 8 because I subtracted 20 from each side of the equation. I've got y equals negative 2. So there is my second solution. Okay, let's go ahead real quick, look at number 1, and I'm just going to pause and let you think about it for a second. But why would number 1 be so easy to solve? Number one is really easy to solve because you don't have to multiply the top equation or the bottom equation by anything. By adding them just as they are, you're going to have these 4x's cancel out. You got a negative 4x on top, positive 4x on bottom, they cancel. So then I've got 3y equals negative 12 plus 6. It's going to be negative 6. So then I end up having y equals negative 2. Now I'm not finished. Ultimately, I would take this back in, plug it in, and solve for x using that y. But I'm not going to really waste time doing that. I think you guys probably know how to do that. So I'm going to go on to number 4. So just to say that again, I've got a y. I need to solve for x to complete this. So I'd plug it back into any one of these equations, whichever one is easiest to get my x value. Going on to number 4. So if I want, well, let me say it this way. If I multiply the top equation by 8 and the bottom equation by negative 6, what would I be trying to get rid of? So just giving you a second to think about it. I'd be trying to get rid of the x's. If I multiply the top by 8, I'd have a positive 48x. If I multiply the bottom by negative 6, I'd have a negative 48x, and they would end up canceling out. Notice I'm just multiplying by these numbers. If I wanted to get rid of the y's, I would multiply by 5 on top and negative 3 on bottom. Or negative 5 on top, positive 3 on bottom. It doesn't really matter which one's negative or which one's positive, as long as one is negative and one is positive. So when you add them, they cancel. So let's go ahead and try that now. Let's say we want to cancel the y's. I'm going to multiply by negative 5 on top. Negative 5 on top, I'm going to multiply by that 3 right here on bottom. So that will simplify to be negative 30x minus 15y equals negative 30. And this one's going to be 8, 16, 24. So I got 24x plus 15y equals 12 times 3 is 36. Let's add them together. Again, the whole reason we did that, the whole reason we multiplied by that scalar in the front, is so that can happen. Now we don't have any y's left. I've got negative 6x that carries down, and then I've got equals a positive 6. So solving for x from here, I'm going to divide by negative 6. I'll find that x equals negative 1. Take that negative 1 and plug it back into any one of these equations. I'll just do this one. I'm going to plug it into the top. So I've got 6 times negative 1 plus 3y equals 6. 6 times negative 1 is negative 6. Add the 6 onto each side, so I've got 3y equals 12. Then divide by 3, so I've got y equals 4. There's my two answers, x and y. All right, I'm going to work one more question. I'm going to go ahead and do number 5. Number 5 is, looks like we're going to have to multiply. It doesn't really matter too much. We can multiply the top by 4 and the bottom by 2. That would work, but there's an even easier way of doing it. And listen, that will always work. If I take this number right here and multiply it on the top and that number and multiply it on the bottom, as long as you make sure one is going to be positive and the other is going to be negative, that will always work. But there's an easier way, so I'm going to do it that way just so you kind of see that. I'm going to multiply by 2 on the top. I'll rewrite that equation right below. So I've got 2 times 2x is 4x. Notice I didn't even multiply the bottom equation, and that's fine. 2 times negative 3y is negative 6y. 2 times 6 is 12. So that's my new equation. I don't even need that up there on the top anymore, really. So now when I add them together, here's something that's interesting that happens. All my variables end up canceling on the left side, leaving me with 0 on the left side. I don't have anything left on the left side. Negative 12 plus 12 also equals 0. At any point, if all of your variables cancel, and only if all your variables cancel, that either means that you have infinite solutions or no solutions. In this case, because when they canceled, it left you with a true statement. 0 does equal 0. That's a true statement. That means there are infinite solutions. Infinite solutions. Okay, so that would be my answer on that one. There are some situations, from what I understood in class, this number 11 right here turns out to be a no solution. So let's go ahead and work that one real quick. I'm going to multiply the top by -2. So I'm going to have -2x minus 6y minus equals -16. So the top equation is pretty much done with. Now when I add these together, that cancels. That cancels. So I'm left with 0 equals 10 plus a -16 is -6. So 0 does not equal -6. Therefore, there are no solutions. All right. That's all I'm going to do on this video for now. And if you guys have questions, you can definitely ask during class, before class, during tutoring. Any of those options would be great. Anyway, guys, I'll see you later, and good luck with